Understanding ROC curve, or receiver operative characteristic curve.
Imagine you have two groups of people, one with condition A, and one healthy group. And you want to find out if you can diagnose condition A by measuring biomarker X. First, let's demonstrate their distributions. Here in the x-axis that we show the level of biomarker X. And in the y-axis, we have either healthy, or condition A. And among healthy people, it is varying between 1.2 and 8.5. As you can see, one healthy person exhibits a very high level of this biomarker, while an individual with condition A does not have a very high level of biomarker X. By applying logistic regression analysis, we can modify the y-axis into the probability of condition A. And by using the probability curve, we can determine the probability of condition A in each subject. Now, one way is to classify the sample based on whether the probability is over or under 50%. As you see, by 50% threshold of probability, we are going to have one false positive and one false negative in each subgroup. But if we adjust the probability threshold to 0.3, then we diagnosed all cases with condition A by having at least 30% probability. By this, we have only one false positive and no false negative. There is one more way to explain it visually. First, we measure the mean and the standard deviation of biomarker X in each group. Then we look at two hypothetical distributions corresponding to the mean values and standard deviations. And by utilizing the midpoint, we can classify them into groups based on values above and below 50%, and in this case 7.7. By this we have one false positive, and one false negative. However, if we want to make sure we don't miss any cases with condition A, we can change the cutoff point to 7.1. Or, if we want to make sure we don't miss any healthy cases, we can go with the cutoff point of 8.3. In these simple examples, we showed how to optimize the cutoff points visually, but in reality we can use ROC curve to verify the best threshold value. Before explaining ROC curve, ensure that you have a clear understanding of the meanings of true positive and true negative, as explained in previous video. So, let's take a look at ROC curve. Here, in y-axis, we have sensitivity of the test, set from 0 to 1. Sensitivity can be calculated as true positives divided by sum of true positives and false negatives. We can also call it true positive rate. And the x-axis, we have false positive rate, calculated by 1 minus specificity, and set from 0 to 1. The false positive rate is calculated by dividing false positives to the sum of false positives and true negatives. True positive rate shows the proportion of cases that correctly classified as positives. And the false positive rate shows the proportion of cases that are incorrectly classified as positives. So, at sensitivity 1, which means all positive cases are diagnosed correctly, we can observe that 72% of negatives are wrongly diagnosed as positives. This also tells us that the specificity is 28%, which is very low. Here we can also calculate the sum of sensitivity and specificity as an index for choosing the optimal cutoff point. In this example, it is 1.28. Now, let's reduce the specificity to 98%. As you see, the proportion of false positives is reduced from 72% into 45%. It also means that the specificity is 55%. At this point, the sum of sensitivity and specificity is 1.53, which is higher than the previous point. This indicates that this cutoff point is better accuracy than the previous one. The optimal point is often associated with the point where accuracy is maximized. In a ROC curve, we can also measure AUC, or the area under the curve. Area under the curve represents the overall performance of the test. And a larger area means a better performance. In this picture, we present the ROC graphs of 3 different tests for the same outcome. And here we can see the measured AUC for each test. As you can see, the larger area belongs to the test, presented in green color, which has better performance than the other 2 tests. In summary, the ROC curve is like a visual guide, telling us how good a binary classification model can put a line between the positive and negative cases. Thank you for watching.